Hi everybody, this is Mr. Folly, and welcome to Podcast 2.3. I'm going to talk about scientific notation, adding sig figs, and multiplying, dividing using sig figs. This is basically just a way of rounding. So we want to make sure that we measure as well as we can. So let's get started with it. Scientific notation is a shortcut to writing zeros. So if your number is bigger than 10, the exponent is positive. So every number will be between 1 and 10. Okay? So here's the decimal point in my mind's eye, and I swing it 1, 2, 3, 4, 5. This gives me 9.5, so that's between 1 and 10. And if I moved it 1, 2, 3, 4, 5, then I have 9.5 E5. That's it. My decimal point in my mind's eye is right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I moved it 9 times, so it's going to be E9. And this number is going to be 3.75. That's it. So this way you can tell, instead of having to write this huge number, you just put the E right here. Another thing that's equivalent to that is 9.5 times 10 to the 5th. Or 3.75 times 10 to the 9th. Books and Mr. Folly use the engineering notation a little more than scientific notation. Okay. If your number is less than 10, by the way, 950,000 is more than $1, right? They're more than 10, and that's more than 10. These are less than 10. So if it's less than 10, the exponent is negative. So I'm going to swing it 1, 2, 3, 4, 5, 6, 7. I stop here because 3.14 is less than 7. I'm sorry, it's less than 1. E negative 7. Because 3 is between 1 and 10. Okay? So again, here we go. 1, 2, 3, 4. 3.04 E negative 4. Negative because it's less than 10, and I have to stop at 3.04 is between 1 and 10. So you've seen those before, but I just want to give it to you. All right, so which is bigger, 550,000 or 5.57 E7? So I'm going to put them both into engineering notation here. So 1, 2, 3, 4, 5, 5.5 E5. Or 5.5 E7. This is bigger, more zeros. All right? 335 or 3.3 E2. So 3.3 E2 would be 1, 2. Now I've got this empty space, so it's going to be 300. That empty space is going to fill with a 0. Okay? 335 is bigger than 330. 7.75 E negative 6 or 7.550. So let's see here. So this one, because this is negative, I've got to make it less than 1. 1, 2, 3, 4, 5, 6. Fill in my zeros. Which one's bigger? That one's way bigger, right? Because this is less than 1. Significant digits are measured. So when we measure things, it's every number that's measured and estimated. Better write that down. And estimated. Better write it down. And estimated. Not guessed at, estimated. Zeros may be significant, but they're usually not. Zeros on the left need a number on the right. Zeros on the left need a number on the right. Zeros on the left need a number on the right. Zeros on the left need a number on the right. Zeros on the right need a number on the left. Zeros on the right need a number on the left. Zeros on the right need a number on the left. Left and right of what? Of decimal. Okay? To do what? To be significant. Okay, so let's take a lookie. This is the decimal point. This is a 0 on the left. It needs a number on the right. No number. Not significant. So 350 has 2 sig figs. And the question is, how many significant figures does it have? This is a 0 on the right side of the decimal. Zeros on the right need a number on the left. Hey, look, there's a number right there. It has it. So that means I have I have 1, 2, 3, 4. This one has 4 sig figs. Oh man, looky here. This is a 0 on the left of the decimal. Get back here. This is a 0 on the left of the decimal. It needs a number on its right, and it has one. Yes. This is a 0 on the left of the decimal. It needs a number on its right, and it has one. Yes. This is a number, non-zero is 1, so it's going to be there. This is a 0 on the right. Uh-oh. A 0 on the right. It needs a number on its left. Hey, there's a 5. Yes. 1, 2, 3, 4, 5. This has 5 sig figs. We'll do a lot more of those. Adding sig figs around to the fewest number of decimal places. So the first thing I'm going to do is put it in my calculator, which is my genius mind. And I have 5, this will be 0, 6, 3, 3. Fewest number of decimals. This one has 2 decimal places. 3.365 would be 3.37. There's my correctly rounded number. 8.1 minus 0.05. Oh, I got to add this one. Get back here. Got to add that 0. 10 minus 5 is 5. Makes this a 0, which makes it a 9, which makes this a 7. 7.95. Now this only has 1 decimal point, right? I had to add the 0. 1 decimal place. So that 1 decimal place, that means this has to have 1 decimal place. So this is going to be 8.0. Multiplying and dividing sig figs. You round to the fewest. That's not right. Why do you do that? Why did I write the wrong thing? Round to the fewest sig. Round to the fewest sig figs. Okay. All these are non-zero numbers. This is 5 sig figs. This, zeros on the right, need a number on the left. Does it have one? Yes! So this has 2 sig figs. So I'm going to put this in my calculator. Dun, dun, dun. And I'm doing the evil thing that you know that I hate when I do, which is using my phone for a calculator, so I might get it wrong. 355.22 times 8 is 2841.76. But I need to round it to 2 sig figs. So I have 28 of my 2 sig figs, and I put these zeros here as placeholders. 2,800. Get back here. Now why? These are zeros on the... These zeros are on the left. And they need a number on the right to be significant. But there's not one. No number on right. So 2841.76 is rounded to 2,800. Okay. So now on this one, it's harder to do on my phone, but 0.0000035 divided by 17. Okay. Now this is a 0 on the right. It needs a number on its left, and it has one. So this has 3 sig figs. This has 2 sig figs. No zeros to worry about there. So the calculator tells me it's 0.12, get back here, 0.1234259. But I need to have, it's a 9. But I need to have 2 sig figs. So these first ones are not significant. But this 0 right here, so I'm going to rewrite this, 0.1234259, okay? And I want to have 2 sig figs. These are my first 2 significant figures. These are zeros on the right, and they need a number on their left, and there is none. So not sig. So my answer is 0.123421. If I were to put that in scientific notation, and I should, it would be 2.1. Get back here. Get back. Oh, where'd you go? It would be 2.1 E negative. Let's see if 1, 2, 3, 4, 5. E negative 5. Okay. So now we'd have 2 sig figs. To review, E positive is bigger than 1. Hey, how about that, right? If E is negative, it's less than 1. Hey, I knew that. Positive and negative, so addition and subtraction, you count decimal places. Multiplication and divide, you count sig figs. Zeros on the left need a number on the right, and don't worry, we get a ton of practice to make this make sense. tomorrow. So I will see you tomorrow, and I'll say toodles.